Guys, thank you so much to everyone who's joining us for this webinar where we are going to talk about the observability imperative. It's based off of a survey report that we'll go into some extraordinary depth on, and I will eventually get to the place where I can turn it over to my experts. But first, I want to go through some logistics. The conversation that we're having here is recorded, and slides will be available afterwards for anyone to download. Please feel free, if you're an attendee, to ask questions in the chat. And if I or another ground cover person, and there should be a couple, don't get to answering those questions in the chat, then we'll try and read out the questions in the Q&A section. So please make sure that you also take time to click into the resources that are available in the Livestorm app. But let's start talking about why we're here. So in April in 2026, we partnered with Atomic Research to survey 500 leaders and individual contributors in the observability space. They shared insights that revealed what trends are showing up in their observability platforms and in the market as the market tries to catch up with the ever-increasing speed that developers are forced to move with. Their patterns of adoption within this expansion of AI driving that speed have revealed three critical themes. Themes of trust, three themes of expense, and one of a future vision for the role that observability will serve. So first, trust, what we saw. Teams see the value of adopting AI within observability specifically. And that's really only when they're able to trust it, which they don't really feel that they can. So we'll go ahead and explain why. Second, a theme of expense. The teams surveyed now call observability data strategic, and yet it's exactly the signal that they are being forced to cut. And we'll explain just how much. And then third, for the future, telemetry's been promoted. Got a promotion and no one told it. It's no longer an after the fact and debugging backstop. It's now a strategic and forward-looking input, which I think some of that, a lot of this audience probably could have seen coming, certainly if you guys hadn't read the actual report itself. So let's start. Let's look at the themes. Trust. What does it mean? How did we come to it? We kind of came to it based off of these numbers. In the report, 87% of respondents said that AI or automation is integrated into their observability workflows. But 34%, a far smaller percentage, say that that integration is fully operational and trusted. That's the 53-point gap, the name of the show. That's why we're here. So Chris P., I want to bring you in early here. Tell me a little bit about what you see in that gap, the space between trust and adoption.
Therein lies the mystery, right, William? That's it. It's that gap in between the numbers. And this is, I think the same thing, if we would have taken this survey 20 years ago when the cloud was just beginning, we may have seen something similar to this, where there's a rush to adoption of new tech, thinking it's going to solve problems right away and cut costs right away and be the savior for everything. I think if we would have seen the adoption of cloud, of course, it took over 10, maybe 12 years for cloud to become really embedded in enterprise. Probably longer than that. There's still companies that are still testing cloud, but I think we would have seen the early cloud apps and the cloud devices and everything else get very high usage early on, and then the trustworthiness of it starting low and then growing. And I think if you were to take this survey or similar survey now to users of cloud, you'll see not a gap at all like that. It would be a much smaller, if not no gap at all between usefulness and the trust of it. It just takes time, and it takes reps, and it takes day over day business and production. So this is not surprising at all to have this involving AI and observability early on. And the amazing thing is that AI is so easy to deploy and use in so many different ways that the trust part is far behind, and we're not catching up to it. In fact, AI is in many ways not trusted at all. I don't trust it very much at all for certain things. I'm looking at a video on social media. I don't know if that's real or not. I have no idea. In fact, I'm taking a seminar myself on how to identify deep fakes, because I need to, as a journalist, I'm always looking for truth. And I need to, before I republish or write on or report on something, I need to know that it's real. But in any case, this number does not surprise me at all, and we can talk about it. Maybe, do you think, William, you think it's worth it just to give a quick definition of observability, just in case some of our watchers don't know about it, or do you think it's pretty well known enough?
Well, it's a pretty mature space, which is why I think that the space that we see here, the gap that we see here, is a little surprising, because observability is so crowded, developed, and you would have imagined that automation built within it would, as a result, start to gain or share some of the trust that people already have in observability's value generally. But ultimately, that's the thesis that we're trying to get to here too, right? So that it's a good thing for you to point out, right? Observability, from our point of view, it's the metrics, logs, and traces, just to recap, that have become sort of standard to the space for your applications, for your infrastructure, for your AI workloads. And those are really the core inputs that you use to create insights about the stability and reliability of your platforms and the applications that you host on them. So important for us to look at that topic again, take a step back and look at the topic and sort of delineate exactly what we're talking about. But within it, there's ample space for automation and artificial intelligence to help the teams who have to think about that every single day. Chris P., if I could just maybe turn to Chris Chirillo, the VP of Marketing here, and I'm realizing now that I didn't even set time aside for us to go through proper intro. So just to quickly bring up the crowd who's here, Chris Primesberger, veteran analyst and writer in the space. Chris Chirillo, VP of Marketing at Ground Cover, industry veteran in technology from data all the way through to observability. Sorry to be so brief about it, but Chris Chirillo, if I could throw it over to you for 1 second. Do you see it the same way as our friend Chris Primesberger, that it's a question of timing in the story of adoption and trust, or is there something else that you sort of saw in these metrics that pointed to a different question of or possible reason of why people don't feel that trust inherently?
I think there's a couple of things that we have to keep in mind. So I think the first thing is, look, AI makes us uncomfortable as human beings. So we are naturally going to not trust this thing because we feel threatened by it, right? That's just how we are, and that's how we reacted in 2023 after the beta of ChatGPT 4 came out. It all exploded,
right?
And nobody believed that this was going to work. And like, how many doomsday articles did we see, right? About, oh my God, developers will no longer have jobs, designers are like obsolete. And so there's a natural skepticism that's going to come with AI as we go through this journey. But the interesting thing is that the reasons behind that skepticism actually has been changing. And so I would argue that in 2023, it was, the outputs were okay. They weren't great, right? We could all tell that it was AI. And then a few, I should say just a few months later, then like we started to really see like hallucinations were ridiculous. And then, over time, we started to realize that, this thing is actually missing context. And once we give it context, then we started to see that, hey, actually, it's starting to do a little bit better job, right? And, so I think this is going to like constantly evolve. We're going to like constantly like make improvements, and then we'll find like, the next thing that we think we need to address to overcome our skepticism. And then, to the point about like in the observability space, it being just logs, traces, metrics, events, I would actually argue that that data set was and is continue to be really important for, our systems. How the service, trying to understand the latency between like a couple of services, or trying to understand the memory consumption of whatever, a database, or, a Kubernetes pod, et cetera. Those things, are well understood, and we've been collecting it for a long time. But our evolution also included different kinds of observability data that we've been starting to collect, because we're starting to realize that there's even more things that we have to observe in order to fix, right? So if we look at observability data today, it includes, or it has to include, tool calls that, your agents are calling, how long that's taking, how many of them are there, what are the prompts and responses that, you're actually giving to the different LLMs. You also need to know like which models and which version, because like these improvements to these models are like changing every, like, I can't even say every day anymore. It's like every minute, it seems like. And then, we have this new problem of token usage, and how do you count that? Inputs and output tokens have, different values, and it can have a really severe impact to a business. And I think the final thing that a lot of people are starting to get to is, how do you now observe whether the outputs were correct? What is correctness? Right? Is correctness like back to, what I said about hallucinations, making sure that, this is accurate? Or is correctness that it wasn't rude? Or was correctness that it understood like a policy that, should have been also embedded into the answer? There's like a ton of ways that we can define correctness, given like what the application is hoping that these, agent workflows are helping them to achieve. And we now need to observe all these things, because it's not just about latency between a database and an API call. It's now everyone has these native agents in their application. So now the task of ensuring that things are right has increased severely. And so it's all of a sudden a lot more data that we have to collect in order to really understand these systems.
So the scope of observability has dramatically increased in recent years. And do you think it's the scale of that data, or something inherent to that scale of the data, that's driving viewer or users, customers looking at the AI built on that data and not trusting what it is that they are seeing?
I think there's two things that are happening. I think one is on that AI layer. So now it's different kinds of data that we have to collect so we can understand that. I think there's another layer that's happening at the same time. And that's, if you think about who was using observability data before all this AI stuff really happened, it was us, right? We would get a page, we'd look at the ticket, we're like, okay, now we got to go and observe and see like who's causing all this like problem. And then, we triage it, which was, always happen in the middle of the night. And then we'd look at other data sources to ensure that we understood the triage. It wasn't just the observability data. It might have been like, you have to look at the ticket. You might have to look at like other documents that might explain how systems were put together. What are the workflows? So we had to look at lots of different places to really make sure that we can understand and triage these things. And what's interesting is like because of cost pressures, a lot of times we sampled a lot of the observability data, because like, I only need, if I have like a 500 error, do I really need all 5,000 instances in the last hour, right? I could probably get away with sampling a lot of that, because I know I'm a human, I'm used to this. But the other thing that's been happening is we're now actually asking agents, or starting to build agents that are going to start doing that job for us. And so, and agents need that context, right? Or they're going to hallucinate. And the last thing you want to do is have these agents that are trying to triage something that's going to be missing a lot of this data. So now we have to rethink our, sampling strategies that we had in place previously. And oftentimes that means that we're going to have to stop oversampling so that we can give these agents a lot more context. So I feel like there's a couple of different angles where it's pointing very clearly why this trust or lack of trust is there, because I think people are starting to realize this data problem is, a lot bigger than we realize. But on the flip side, I think people are excited about these possibilities. So they're also willing to dig into it and understand it. So it's not, I don't feel like it's more like, oh, we're completely skeptical, we're worried it's going to take over my job. I think it's more now in this, yeah, we have this problem, but I'm willing to now dig into it and learn about it.
Chris, does that ring true to you, Chris Prensberger?
Well, Chris Shrillo knows more about this than I do, but well, I mean, it's your business. So I look at it from a slightly different standpoint. We've always had more data than we expected. It seems like there's always more data out there. How do you account for it? How do you trust it? How do you store it? And that's where I come in. Data has to live somewhere. All data, and it's in storage. That's where I started at eWeek as the storage reporter years ago, and it turned into a cloud beat right away in 2006 with S3 when that was released by AWS. And the data thing has been so huge and so, I think, uncontrollable. Data, in my opinion, is almost uncontrollable. We think we can control it, but there's always new data, and how do we account for it? How do we use it to help our businesses? That's what the challenge is for IT. I just wrote a piece a week ago or so in the New Stack about token maxing. And, when AI came big to the party a few years ago, companies in general wanted to use as much AI as they could in everything, not knowing exactly where that direction was headed. They just wanted to use it and check it out, and they didn't care what the costs were. Well, that is starting to back up on them because the cost, it turns out, using too many tokens in AI is expensive, very expensive. And when the bill collector comes, a lot of companies are surprised. Again, data, going crazy with data and using too many tokens. It's all part of the same picture. Controlling a company's information, keeping it safe and secure, and making it available whenever an employee needs it. Now, how does that relate to our discussion today? Well, it's all about the same topic. We're all talking about data and data insights. And I think Chris is looking at it from a developer standpoint, which is the way to do it. I'm looking at it from a business standpoint. And it looks like the token maxing party is over right now. That's what my headline said in the New Stack. Because there's a couple of companies that are really taking charge of that and trying to control it. But I just don't think our data can be controlled very well, even with all the good tech we have today. I just don't think we are there yet. We're like we were 20 years ago with cloud. We weren't there at the very beginning of cloud. Right now with AI, everything's exploding in so many different directions. There's like Chris said, there's so much more data, and there's so many more layers that we have to deal with now. It gets very complicated.
Well, It
don't,
certainly is an
we don't
interesting
have-
moment of data scale, right?
Yeah, well, exactly. And if we can't automate much of this and trust that automation, we're in deep doo-doo.
Well, to call out the other stat here, we talked about the 53-point gap and the space between it.
Yeah.
What's pretty clear is that it does seem like it's a data problem, maybe in a slightly different framing as we've been discussing it so far. If we look at the stats, only 22% of the respondents felt very confident that they were getting enough high fidelity signal. And
How
Chris,
do you define high fidelity signal? Just
yeah, and Chris, I'm sorry, I'm getting a little bit of echo on my side. I don't know if Chris Churla, you can hear that as well.
Yes, I can.
No, you're okay.
High fidelity signal being the high fidelity signal being the kinds of quality data that you need to actually debug or.
Okay.
Oh, sorry, Chris, I'm still getting pretty significant feedback.
You're okay.
I'm gonna mute you for a second. Sorry, Chris. I just was getting super loud feedback, so I'll unmute you in a second. I think I can ask you to unmute. Yeah. So high fidelity signal. The point of that is that it's data rich enough for teams to use it for debug or for tracing issues throughout their platform or throughout their applications. So it's really important. It's an important measure of quality, right? That's essentially a measure of quality. And when it relates to AI issues in particular, that's an important thing for us, right? We want to make sure that we have sufficient quality data. So we were talking about the overwhelming story, the story of overwhelming data for IT teams. That's totally a reasonable problem to think about, especially in historical context. But what we see is that there are actually very few members of this survey group who felt that they had felt very confident that they had enough of that high fidelity data to do the kinds of critical tracking that they are tasked with on a day-to-day basis as a part of the platform teams.
Okay, gotcha.
So
okay, so does that mean that that's edited data that's already been through an editing cycle?
Yeah, typically you don't want to edit observability data, right? Because if you think about it, it should be a record in time of what happened, right? So it should be immutable. Now, sometimes data comes in late, or sometimes you do have to make like some small changes to it, but theoretically you shouldn't be, because it's supposed to represent like what that failure was, so then you can go back and try to fix it.
All right.
Yeah, that's right. And very confident in this survey was the highest measure of confidence that their data was sufficiently rich for them to be able to fix the problems that they were seeing. I'm just going to add in that only 50% are confident at all that they have sufficiently rich data. So a measure or the combination of this and a measure lower in terms of their overall confidence scores. As the combined group, 50% are willing to say that they feel like they can trace problems throughout their infrastructure at all. So you're right that there might be an overwhelming flow of data, Chris Primesberger, in the IT world, but the developers who are trying to keep applications and their ecosystems alive and healthy don't know if they're observing sufficient volumes of high quality data for their purposes.
So therein lies the rub.
Therein lies the rub. I think that we've talked a lot about trust and the importance here of finding the right quality of data for teams to actually be able to confidently look at their observability platforms and say that they can fix an issue. I think that there's an important paradigm to keep in mind here, which is that there is so much data, as you and as both Chris's have spoken about. Finding out what data is important to trust is often a decision that these observability teams don't get to make for themselves. They're sort of forced to go through this sampling exercise. And that's going to lead us to our next theme that we observe throughout the platform, because they are forced by virtue of expense. The observability teams, platform teams, engineers who responded to our observability survey felt that there were a lot of overlapping patterns of cost that were impacting how they thought about observability. And it's probably not surprising to hear that a survey from teams on observability uncovered expenses as a key theme. It's often seen as a cost driver, and that sometimes causes some agita, some anxiety. It's probably also not surprising, though, that they're investing in the capabilities to observe their AI workloads, right? So let's talk a little bit about, even despite the fact that cost is often a top thought, it's still observability for AI is still a piece that teams are investing in heavily. Off the top, 50% of organizations or thereabout say that they are spending to the tune of 26 to 50% of their observability spend already on AI workloads.
Yeah.
And 61% of the respondents say that they spend at least $1 million a year on observability for our survey respondents. Those are kind of eye-watering numbers.
Yeah.
And the breakdown of the paper brings you as a reader into some more depth for each of those, with different segments and slightly different spins. But I want to pass it off to Chris Cirillo this time first. Do those numbers surprise you? You spend a lot of time focusing on the market as a marketing leader, and having been in the space for a sufficient time to have accrued expertise. Do you see that companies are, does this feel like it's commensurate with where you think companies are in terms of early or late in terms of their adoption of observing AI? Like, how does this sort of read to you?
I mean, it doesn't even have to do with AI. Just if you think about the data you need to collect, for your systems, if you just think about the characteristics of observability data, there's 3 characteristics that will easily contribute to a ton of data and expense. The first characteristic is like high cardinality. So, unique values that you need to have. Maybe it's a user ID or a session ID. Sometimes you need that information to be able to troubleshoot what's actually happening, right? High dimensionality. Sometimes you have to have all this metadata around your observability that can explain things like deployment version or region, or maybe a specific hardware. There's this other information that gives context about, the trace, because maybe it's only happening on this particular server, et cetera. And then the third thing is just that, to just add on to get that complete context, right? In traditional systems, we're talking about payload. All the little details, like what did you actually send in that request to the database? Was it customer's credit card, their name? Like, what is it that you send that could have caused, that error? And this is just in traditional observability. Having all that information, it just adds up. And that's why, it's naturally going to get like very, very expensive. And that's why we all felt the need to sample. And it just gets worse with AI data, because like context now, it's not the payload is now the prompt and the response, right? That
Right.
has a ton of information in there potentially. And then as mentioned before, right, there's also like, the token usage. It's kind of ironic, right? So we're collecting data about token usage so that we can then like save on expense. But you got to collect that data to be able to see that. I mean, the whole thing is actually very ironic, because we've been sampling it so we can save money, but you collect that data so that you can get visibility, so you can debug something that might actually cause failures that might cost you a lot of money. I mean,
Right.
there's such irony in this whole thing, right? It's supposed to save you, but you're not allowed to collect it because you're getting in trouble because it's too expensive.
Yep. Chris P, do you look at that 61% of respondents and think that that makes sense, or does that seem like that's a surprising amount for early 2026?
It's a little surprising to me that it's that high, but maybe it shouldn't be. But I would bet 5 years ago, even that would be next to nothing. It's only been the last few meaning 3 years that is starting to climb like that, and it's early, and so it's going to continue to go up. I think I was looking at what some of these tools cost just a couple of years ago. Observability tools, anywhere from free, of course, open source point solutions, to over 50,000 a month. Well, it's gone way beyond that, according to this. So it's rising incredibly fast, just like the use of AI. It parallels it completely. And I think that's actually the industry benchmarks. I found a note that says industry benchmarks suggest that observability spend should ideally sit around 5 to 15% of total infrastructure costs. I think this is way past that. How does that bode for the future? I don't know, but it's like tokenization. Companies were going crazy buying tokens and using them in their production. And now they're cutting way back all of a sudden. Not all of a sudden, but the last year or so, they're cutting way back. They're realizing how expensive it is. 61%, yeah, it's gonna go up a little bit before it goes back down, I think, for sure.
Well, the survey showed that teams are already responding. They're looking for ways to naturally respond to those cost pressures in pretty predictable ways. Sampling, renegotiating contracts, exploring things like open source alternatives to their established vendors. I think that we could have predicted that was going to happen in the observability space as these bills have grown large and the workloads are getting increasingly complex and going to drive those large workloads further up. Chrissy, do you see any surprising scale in the response statistic there of nearly 80% of teams that are trying to adjust to these cost pressures, or is that not surprising to you?
It's not surprising at all. I mean, like, just ask any developer about what their retention policy is, right? If they could, they'd love to have, I don't know, some crazy 6-month, 1-year retention policy, but it's like 30 days, 14 days. We've been doing this for quite some time. I think we just haven't been really honest with ourselves about, what would be ideal if we could collect it all. And, we weren't really hurt by it. But I think we might start to be hurt by it because of, trying to introduce these AI agents that might need a little bit more of that context.
Yeah. Well, the agentic layer is hungry for context. That is to be sure. And if you don't give it to it, you run into the stats that we saw before, that 53-point gap where people have deployed AI because it's Chris P, to your point, Chris Prinesberger, to your point, it's easy to deploy. But if it doesn't have the right context, you burn that trust so quickly, so immediately. And clearly the developer engineering teams that are trying to harness that potential power of artificial intelligence are feeling burned on both ends. They can't trust the AI, but they also can't sample, or they're being forced to sample and can't retain the kinds of data that they need in order to get to a place where they actually could trust the outcomes and have it drive fully functional automation with their observability data. Entirely predictable that a cost pressure like this, where increasing costs are inevitable, was going to burn the trust capital that we are trying to build into our AI and agentic solutions. So I think that the 53-point gap is starting to take some more color here as to how and why we got to this stage.
Absolutely.
I think that one of the interesting things, though, is that there is still inherent in the data, the survey data that we saw, a future vision, a story of where observability data is pushing the users and the leaders who we surveyed. There's an opportunity, obviously, to close that 53-point gap between trust and adoption. And I think that that's important because when you look at how teams want to use this data, it's for forward-looking decision-making. I mean, 90% of respondents, nearly 90% of respondents from the firms and these individual contributors see it as a key pillar for forward-looking decision-making and prioritizing. If you compare that with the reality that they are also, for the most part, being told to cut back on observability data, that seems like a vision which will be hard to realize. Chris P., I'm wondering if you see any narratives that parallel this from your experience, or that you have any more data to support that idea that observability is an important input for decision-making for the future.
Well, of course it is. And it's important for decision-making, not only by humans, but by agents, agentic agents too, which are going to be making more and more decisions in production as we go along. We need to trust those agents, and there's still a trust gap, I think, there also. I don't think a lot of those are mature enough to be used on a daily basis. They are being used in many cases, but there's still hallucinations. There's still errors that get into these systems and cause problems. And I think these things all kind of tend to work themselves out in time, has been my experience. Starting with some of the, I mean, I could cite the examples that I mentioned before of the cloud and mobile and other things. Those new techs come in, we use them. Some work, some don't. The companies, winnow themselves out over time for the winners and losers, and it's just a matter of placing our bets on systems that we maybe have used in the past, or companies we've used in the past, and continuing to stay with them going forward.
I hear what you're saying.
I mean, that's what it is. And humans make those decisions, but lots of smaller and other decisions are made by automatons down the line.
Well, the snowball effect of systems down the line, depending on that data, is also pretty obvious from the stats. Nearly 50%, excuse me, of the respondents are connecting their telemetry data to external systems or to some sort of agentic layer on top. And that's pretty critical because that moves your observability stack from being something that you simply for a retrospective, and all of a sudden, if it goes out, your production systems are going to get impacted. And so a 5-minute outage from your observability data or your observability vendor becomes a sort of knot in the hose of those downstream applications. You're not getting the water that you need. Chris, does the role of telemetry data, Chris C, that is, does the role of telemetry data in downstream systems seem like a natural end result to you too?
I mean, we've all seen the cursor codex, name your favorite tool, write code on behalf of an engineer. And then they're like, oh yeah, I'm going to open up a PR in GitHub, and then we're going to push it through. We've all seen that, right? And then some developers have actually gone fully, using all agents to write code, and they're not writing code themselves. But in order to do it in a very safe way, you do need some of that. You need context from telemetry data. You need context from ticketing systems. You need context from a bunch of different places that is going to explain like what's going on, right? Because I could build something and all of a sudden I have my query is going like wonky. I don't understand why. And then it could be so bad that, maybe that query is then triggering retries that's going to trigger like a ton of token usage. So it could become really, really painful. But if you didn't know that the index in a database was like deleted, you wouldn't know to potentially avoid those kinds of things. So I don't think it's just telemetry data. I think it's all the data that surrounds a developer and being able to write code, to understand their systems, to understand like what's just about to happen. What did someone else do? But I do think telemetry data is like one of the key important data sources, for those kinds of workflows.
Yeah, well said. Well, the summarization from these key themes is interesting as we sort of break it out by the story of company size and also what it means for our audience, right? When you look at this data and want to know the answers to the question of what it means for you, whether you're ahead or behind, it kind of depends what segment you fall into, right? And who it is that you want to compete with. It's important for people to remember that the folks that might be playing in your current stage might not actually be the exact set of people that you want to be competing with. You want to try and move up market and take market share from other folks. So like, what are they doing that you need to try and match to? In this, we saw that in the early stage, only 22% of respondents said that they enjoy comprehensive observability, which is comprehensive observability is the highest measure of confidence that users express when talking about their observability. And it's specifically confidence that their tools capture sufficient high fidelity data, to come back to that term, CRISP, when it comes to detecting real AI issues. So this group, a very small subset of early stage companies, feel confident that their observability vendors are enabling them to get to a place to truly detect real AI issues, which is fascinating. As a subset of this, by the way, only 21% would claim that their end-to-end observability and the visibility into that end-to-end observability is excellent, which full visibility across your AI systems is another measure of confidence, which is important and not a stat on screen, but still an interesting talking point. I think that it's pretty obvious to a lot of us that those early stage companies that are scaling their organizations would benefit from quickly establishing their own personal ROI on how their observability impacts their organization and commit to it before they try to aggressively scale their observability. They have to kind of decide like what is mission critical if they're going to effectively compete against the mid-market set of respondents who say that they are fairly confident. There's a higher rating of confidence. 26% would say that they enjoy the highest rating of comprehensive observability when they were asked how confident that their observability platforms actually capture that sufficient high fidelity data. But that mid-market group is also interesting because a fairly large, nearly a fifth of them, for a segment, are considering consolidating their tooling, right? They're looking at their tooling and saying that they have to implement adaptive sampling in some way, or telemetry tiering. And they're considering, as a larger group, adding more sampling in this coming year. So clearly there's this gap, right? 26% of these folks feel that highest level of confidence. And so few of them feel like they can confidently diagnose the issues without having to introduce more and more sampling in their sort of observability stack, their telemetry data. And that's interesting, especially when you look at who they're competing against or trying to compete against in the enterprise. I think at one point, Chris Primesberger, you were talking about looking at the established players and who it is that we can trust. Well, that's a very confident group here. 65% of respondents in this category say that the average time that it takes to detect and then resolve AI application incidents is at most a day. 28% detected related incidents within minutes and resolved within the hour. And then 37% of them detected within hours and then resolved within the day. So when it comes to observability, the enterprise group has substantial confidence that they've deployed it in sufficient width and depth that they are going to be able to resolve incidents quickly. And if you are a mid-market or an early stage company that's trying to compete against that enterprise, that's an important thing for you to remember. It's reliability is a differentiating factor for them, right? It's the bar that you have to meet, and they are raising that bar all the time. They're also weaving AI-driven automation and recommendations into their platforms. Nearly 37% of them are adopting AI workloads into their observability platforms. And it's a really hard and cumbersome effort for those startups and mid-market groups to try and catch up, because they are moving with speed too. The enterprise group is. So what do you do? What are the takeaways? How do we get you caught up with the enterprise if you're a part of that group? Well, the playbook is kind of clear, actually. You have to eliminate your blind spots. And the reality is that you should be able to pick which are the blind spots that you're okay with, right? Don't let your observability bills or the fear of a spike dictate that choice for you. We know that not every data point is critical, but you should be the one that's deciding what blind spots you're okay with. Second, measure what matters. Like I said, not every data point matters. Not everyone is a signal. And after you've observed something long enough, you can make that choice about what it is that matters and measure that thing. There's a trend across the space. And Chris, I'm so sorry. I'm going to put you back on mute real quick because I'm getting an echo again.
Okay.
All good. The trend across the space that we've seen that I think is important for our folks trying to catch the enterprise to be aware of, which is consolidation, right? Get out of that sort of swivel chair crisis management experience. If you're in the startup and mid-market group, because it is going to be a detractor for you ultimately when it comes to resolving incidents if you're switching from one place to the next and trying to keep your applications and systems healthy. Fourth, design for AI systems. They're going to be your connective tissue. That might be a differentiator for you, and your agents or someone else's agents might be a customer in the future. Design your observability stack for that and that reality. Fifth, embrace open telemetry. I think that that's a pretty obvious recommendation for a lot of folks here, but just to talk about it, it's as a standard, it will support in the future the investments that you make now, especially as you start to scale your AI systems. And then finally, connect your architecture to your costs and to your controls, but don't let your architecture be dictated by them, or don't let your investments in the data for your infrastructure be dictated by them. Your observability doesn't have to be forever handcuffed to some SaaS platform. You can control your architecture in your own ways. And that's it. I'm so appreciative of Chris Cirillo and Chris Primesberger, you guys both joining. First, I want to offer my thanks to you guys for spending some time with us while we host this conversation. For the people who are viewing this now or in a recording in the future, first things first, make sure you scan the QR code to download your copy of the report. And while you're doing that, if for some reason you ended up here and you don't know about ground cover, you should know. But let me just tell you quickly about us. We're a BYOC first full stack observability platform. That's in contrast to SaaS observability. And the deployment model allows ground cover customers to keep their sensitive data and high volume telemetry data in their own clouds. That means that they don't have to worry about paying for hosting fees and compliance concerns. And their compliance risks just dramatically decrease with that model. Also, as a result, our customers can keep up to 10 times the data volumes that they would as compared to a SaaS observability platform, and it's far more secure. If you want to experience it on our data, try the playground at play.groundcover.com. If you don't understand how this kind of observability would fit into your ecosystem, book a conversation with a solutions architect at groundcover.com/book-a-demo. Thanks everyone so much for joining. Again, Chris and Chris, thank you guys so much for spending the time with me.